This is the sixth and final video in the Road 1 Chapter 8 cross-section labeling chapter. 8.5 individual exercise, create, cut, fill volumes for ramp 4. First thing that we want to do is make sure our final feature definition, which is the old design stage SS and SS4, is set to 1 final. So in the background I have MicroStation open. I have it open to the corridors ramp 4. That's the only place you can control this. So we're going to select that corridor for ramp 4, and then I'm going to go out to the properties on the heads-up display and verify the feature definition does say final of 1. We have preliminaries in there and we have final. So that step 1 is complete. It looks good. It's been verified. Next thing we want to do is create an earthwork file for its own calculations. We'll do that. It's a 2D file. So we'll go over to MicroStation again, do a file, new. Make sure our source document is MoDOT Design Seed 2D, and then we'll give it a name. And the name we're going to give it is earthwork underscore ramp dash 4 underscore J5P 3181. Hit OK on that, and we'll let ProjectWise and MicroStation create this file for us, which will take a few moments before the check-in dialog pops in. Okay, the check-in dial-in is here. We'll check it in. Okay, so our blank file has opened. We'll go back to our instructions. And our next part, step 4, is open the reality modeling workflow group. We can do that. And then select the coordinate system icon and attach the coordinate system by file. And we'll use the corridors ramp 4 J5P 3181 file to do so. So we're going to do all that. We're going to open up the reality modeling workflow, step 4. Step 5, select the coordinate system icon and apply from the corridors ramp 4. Right, open roads, we'll change it to reality modeling. Go over to coordinate system on the far right. We'll choose from file. We're going to use our corridors for ramp 4. Since we already applied it to that corridor in that file, we'll hit open. We'll select it by hitting OK. It populates our geographic coordinate system. We can close that down. So back at the instructions, step 6 says let's change the workflow back to open roads modeling. And then step 7 says attach the following files as reference files. Do not use live nesting for end area volumes, or more files will be attached than you need. So if we're trying to calculate for just the corridor of ramp 4 and we use live nesting and it brings in anything attached to our corridor for ramp 4, you're going to get that Route 54. We don't want to do that. We just want just ramp 4 in the civil geometry and the terrain. That's all we need. So let's go back to MicroStation. Change our workflow to open roads modeling. We'll go to the home tab and we'll go to the references icon, tools, attach, verifying you're in the correct data folder. We want to bring in the corridors ramp 4. Holding the control key down, we'll scroll down and we can pick up that civil geometry and the terrain just by selecting them, and then left click to the add. It populates those 3 files that we want brought across as references. Then we hit the OK button. It'll tell us it does not belong to the active work set. Do you want to continue? Yes, we do. And then this dialog will pop up, which this is where we want to verify we have 0 as nesting depth. If you have it at 1, change it to 0. We want 0 on this. Hit OK once, twice, 3 times. We can close out of a reference dialog and then maximize our view and zoom in, and you can see that we now have that ramp 4 corridor, our terrain, and then the civil geometry as well. Okay. Now step 7 says make the terrain J5P3181 as the active terrain, active surface, so we'll do that. And it also says in step 8 to select the F6 button to open up the 3D model view. So let's go back and do that. First thing I wanted us to do is select the terrain, anywhere on the terrain. Get your heads-up display. And then the second icon is set as active terrain model. And we need our terrain as active so it can see the existing ground in our cross sections. The other part of it is that we want to do an F6 and see the 3D model. When we create our name boundaries, we want to have that second window open with the 3D. So the easiest way to do this is to zoom into your route or ramp 4 and then hit the F6 key. And it's going to give us our ramp 4 in a 2D, and then on the right side it'll give it a 3D model view. Okay, so that completes those steps. Step number 9 says from the Drawing Production tab, select the Place Name Boundary tool. Then we're going to change it to select the Civil Cross-Section icon, and we're going to use the 5 scale. So let's do that real quick. We're going to change our tab to Drawing Production. Looking through the ribbons, we're looking for that name boundary. We're going to select it. Make sure it's on Civil Cross Sections. This is the 4th icon over. We're going to use a D-size 5 scale. And then we're going to go out and pick our ramp. So we'll select it. Once we do, it populates our name, ramp 4. We're good to go on those steps. So now it wants us to start and stop. Beginning of the alignment will be the start, and the stop location will be 5 plus 0, 0. Okay. So go back over into MicroStation. And the way I like to do is start. You can do it many ways. You can come beyond the start location and just left click. Or you can select in here and key in what you want. Or you can hit this button off to the right that locks it to the start path. Would be good. Now you can see it's rubber banding off my cursor to apply the other stations. I want to go down to my stop station and change that to 5 plus 0, 0 and hit the enter key to lock that in. When I come out on my screen, you can see it's ready to go. Now, the way this works with the left and right offset for a 5 scale sheet is we have 140 feet to work with. So we'll go back to our Word document and see what we got here. We want to go left of minus 40 and then right offset of 100 and the interval of 50. So our left offset we're going to do is minus 40. And then we're going to go to 100 for our right. You want it to not be more than what the sheet calls for, or else it won't fit within the sheet. So 140 is the maximum allowed distance inside that 5 scale sheet, and we're going to use it. We're just going to move it over, and you can see that there's a retaining wall out here, so we don't need that much on that left side. That would be more Route 54's territory. So we're just going to make sure we get that right side and a little bit of the left side. So it allows us to adjust this. The create drawing must be checked on and show dialog must be checked on as well. And the reason that is because if we check those on, then we get the next dialog to pop up, which lets us pick the annotation. And the annotation we're going to pick is this one without grid. So let's go back over to our tool. It's ready to go. The interval's at 50. We have create checked on, shows checked on. We'll go ahead and left click to place the first part of it, and then we'll accept it. And it's going to go out. It's going to put our shapes out there. And then what we're going to do is we're going to change our annotation group. You hit the pull down in the middle of the dialog, navigate around some of the heads-up displays, and then we're going to pick that annotation without grid. The other option is that we're going to turn off is the open model option, and it says it in the manual, which is part of step 15. We want that unchecked. The reason is we're going to go do some other tools, and so we're going to use the create mesh tool to get our surface, and we don't want to do that in a model or in a drawing model or design model or sheet model. We want to do it in the multi-model that we have open. So we'll just go ahead and hit the OK button after we place that. We'll let it run. It'll create the sheets in the background. You can see on the right side my transparency is not turned on in that 3D model. We can do that real quick. Change that so we can see through those shapes. Let's look at what I got here. So once we've done that, we've got our shapes out there, we've got our sheets, and you can see that the sheets have been created. You can see the sheet views, and if you scroll up, you'll see here's the drawing views. Okay, so they're all there. Everything's been created. We're going to stay at where we're at in the multi-model view. Now, we need to create the cut and fill volumes. This process will create a mesh surface for each of the cut and fill material for extracting quantities. To do this, and actually I'm just going to take this, move it over here so I can see some of these instructions maybe. And minimize this a little bit, like so. So it says from the Home tab, so we'll go over to our Home tab. It says select a civil analysis pull down. That's the ribbon over here. We'll hit that civil analysis pull down and then select the create cut and fills tool. That's about halfway down, a little past halfway. Okay. It opens up a dialog. This dialog will be pre-filled out with the cut and fills feature definition. We're good to go on that. Let's see what our instructions say. I'll have to move it over a little bit to read it. The dialog will open and will allow the user to specify a cut and fill definition and feature definition. So we already talked about that. All we need to do is accept through the options and the blank area. Okay. So we'll do that. We'll go over to MicroStation. We'll do that again. So let me try that one more time. There we go. And then data point to accept the selection, and it's going to go out and it's going to crank, and there's a dialog on my other screen that's going, a little bitty one. And you can see the cut and fill as it appears with the red and blue coloring. Okay. The next part of this is that we need to do the end area volume reporting. This is the only way we can populate the end area volumes on the sheets. So what we need to do is open up the report tool and then choose the ramp 4 name boundary. Okay, so let's do that. So we go back to where we were at. It's under the civil analysis, end area volumes report. We'll select it. Right now, set to none. I'm going to hit my arrows to go to, or to choose my option of ramp 4. Go ahead and select in a blank area. And then the next part of this is you can select to remove shapes that you don't want to calculate. Or if you've got everything in there that you want, you can simply just reset or right click to advance the tool. So we'll go ahead and right click. It's going to go out, create this XML report. And it's going to default to this end area volumes XSL. Now, going back to the manual, there's some stuff in the format that we need to look at because the angular and the station, cubic units, and direction default to something different than what we want. So to change that, you just come over to the report, go to your tools pull down, go to the format options, and then here's where we can change those numbers. So we're going to change our stationing to English stationing. We're going to change our degrees to degrees, minutes, and seconds. And then we're also going to click on convert to cubic yards since we're doing earthwork. Now nothing happens in ORD until you close the dialog. So we've changed our settings. We'll close. It's changed. Now we've got good English stationing on there and we're good to go. Okay. So the importance of this whole thing, and I'm going to go ahead and minimize this, is that in this 3D window, these shapes get assigned in XML. Before we run that XML report, you don't get anything. But if I click on it now and I go to properties, I go to name boundaries, I open that up, I can see down here under civil properties, there's now an end area volume XML fragment attached to that shape that has the information for our calculations. Okay. So now what we need to do, let's go back to the manual. Yep, it's created the end area volume report. And then we want to open up a drawing model. For this one, I guess we're going to do 2 plus 0, 0. So we're going to the drawing and not the sheet. The sheet model says sheet on it. We go to 2 plus 0, 0 in the view. And you can see we have some calculations out there. We have our, not calculations, we have our stationing and our annotation for the cross section. We can apply the annotation for the earthwork just by applying another annotation to it. So to do this, we'll apply it by using the annotate model tool, and we're going to yes to all annotate models. So let's do that. You can find that annotate tool under the drawing production, and it should be the default one at the top, model annotation. We want yes, so you can either check on this dialog, this box, or you can hit the up, down arrows. But I'm going to hit yes to that, and then I'm going to go back to the, sure I am. I'm going to go back to Word, and it's going to tell me that we want to use the triple dot box to open the annotation group, pick list, and navigate by opening the cross-section folder, the drawing folder, and then select the cross-section EAV annotation. So XS EAV annotation. So that box is right here. It's got 3 dots. We'll select it. It pops up on my other screen. We'll open our cross sections, drawing, and we're going to pick this XS EAV annotation. It's on my cursor. Now all I need to do is left click and let it run. It's going to go through each and every one of those models, and it's going to place us a box up here in the top right that has our cut and fill information. Okay, except through that, it gives us that. And then we want to compare it to the report just to check the earthwork. So we can do that. So if I bring up my report, there it is. We can look at some of this stuff. So let's see which report we're using here. Volumes. We want to go to 2 plus 0, 0. And then here you can see it 2 plus 0, 0. And I changed the report to the volumes report so I can zoom in to 2 plus 0, 0. And you can see the cut area is 38.3. And our fill area is 191.1. And then you have your adjusted volumes. That matches. This one matches. So we're good to go. Back to the manual. And I believe that is end of exercise.